Right. Exercise 11 on page 355. It says find the sum of all multiples of 6 between 50 and 500. Easy. Easy. So we need all the multiples of 6 between 50 and 500. So what's the first multiple of 6 over 50? Well, we know that from our times tables. It's 54, because 54 is a multiple of 6, 48 is a multiple of 6. That is the first multiple of 6 over 50. So it's going to look something like this, and it's going to go as far as the last multiple of 6 under 500. Now, 500 is not a multiple of 6. I can tell you right now, because 500 divided by 6 is going to be some strange number. So I'm just going to take a guess here. Let's say 495 divided by 6. Now that's 82.5. So what about 498 divided by 6 equals 83. So 498. So 498 is our last one, and we just did that with a little bit of trial and error. And so we know the first term, we know the last term. We don't know how many terms there are, but who cares about that right now. We should be able to find out using, oh geez, we don't know the number of terms. We don't know the number of terms. Well, we can use this to reverse engineer it and find out the number of terms, because we know that the last term is 498, and we know the first term, and we know there's a distance of 6. So we should be able to use this formula here to reverse engineer it to find out how many terms there are. And once we know how many terms there are, we can use this formula to calculate what the sum is. So you go ahead and do that. Pause the video, see if you can do it. Find out the number of terms using this formula, then use this formula to determine the sum. Okay, we're back again. We're using Tn equals a plus n minus 1d to find out what term this is. We know that T1, of course, is, or A, whatever you want to call it, or A1, is 54. We know that there's a distance of 6 between them, and we know that the last term is 498. So 498 equals 54 plus n minus 1 times 6. And if we work that through, 498 equals 54 plus 6n minus 6, which equals 6n plus 48, 498. So we take 48 off both sides, 450 equals 6n, and n therefore equals 75. Is that right? Yes, indeed. So n equals 75. So this is number 75. And given that, we can use this formula to determine the sum. And the sum then equals 75 over 2 times 54 plus 498, which equals 75 over 2 times 552, which equals 75 times, I'm just dividing this by 2 instead of the 75. It'll work out the same. That's 250, 275, 276. And that is a great big number which will require the use of my calculator. 75 times 276 equals 20,700 is our answer.